Hello everyone, welcome to another episode from CADEXCEL. Today I am going to talk to you about the variation of the boiling point of a molecule depending on their forces of attraction. So the last video we discussed about the water solubility and what are the factors depends on substance to dissolve in water. So today I am going to talk about the boiling point of a molecule. So you better go to that video as well. I put a link on the top, so you can go through that as well. So today we are going to talk about how the boiling point of a molecule gets varied depending on the forces of attraction. Now the boiling point, we have a definition, but we rarely use it in chemistry in Excel. The general definition for the boiling point is, normally what we know in the boiling point is the temperature at which the liquid start to get boiled, right? That is a boiling point. But it is not specifically a certain value, because you can see the water start to get evaporated or boil during the process of heating as well. So it does not happen suddenly. You can see bubbles come from the bottom and suddenly the whole solution starts to boil. But what is the exact definition? So it is not exactly a certain place or the certain temperature. It starts to boil from a certain temperature onwards. Anyway, the definition for the boiling point is, it is the temperature at which the atmospheric vapor pressure is equal to the saturated vapor pressure of a liquid, which is quite hard to understand. As we do not have it, I am not going to explain it further as well. So simple idea is, if the vapor pressure from the outside is equal to the pressure inside the liquid, it starts to boil. That is the temperature at which we call as the boiling point. So boiling point is directly proportional to the forces of attraction. Higher the stronger the forces of attraction, the molecules are tidally get bonded in the liquid state, so they do not tend to get evaporated easily. So the boiling point will be high. So if you take simple three molecules like CCl4, carbon tetrachloride, and H2O, and another one we take it as let us say CH3 CH2Cl, right. So the boiling point of these molecules are different. If we ask to predict, this is 100% nonpolar, so let us say CH4 for easily, 100% nonpolar, so it only contains London forces. H2O is a liquid which contains hydrogen bonding. CH3 CH2Cl is a polar molecules because of the Cl part, so it has permanent dipole attractive force, right. So usually the boiling point should be H2O should be the highest, then would be the CH3 CH2Cl, then it is CH4. So I did not mention anything about the boiling point values, I just mentioned about what it would be the boiling point because of the forces of attraction, right. So I will put a exact value for this. So where H2O is normally, we know that one, which is 100, right. CH3 CH2Cl and CH4, the values I will put on the screen. Now sometimes the permanent dipole attractive forces are there, but sometimes if the London forces strength gets really high, the boiling point gets mainly depend on the London forces strength. So mainly the common example they ask us is to explain about the boiling point of hydrogen halides, HF, HCl, HBr and HI. So let us say this is a molar mass and this is boiling point. So HF has the least number of electrons, or other way around we can say it has the weakest London forces, but HF has intermolecular hydrogen bonding. Therefore HF has the highest boiling point. When you talk about HCl, HBr and HI, they all are polar, they do not have intermolecular hydrogen bonding, but the HCl is the most polar, which means it has the strongest permanent dipole attractive forces. Hi has the weakest permanent dipole attractive forces. But you can see the boiling point increases like this. HCl has the lowest among HCl, HBr and Hi. Hi has the highest. The reason there is the London forces is much higher in Hi because it has more electrons. So in this particular case, HCl, HBr and Hi, the more predominant forces of attraction would be London forces. So as Hi has the highest London forces strength, it has the second highest boiling point, but still it is lower than HF, right? HF, HCl, HBr and Hi, this is like that. So still it is much less than the boiling point of HF, right? So Hi is the second highest, HCl is the lowest. This is a very common one they have asked in the MCQs as well, right? So simple idea is, if the molecule contains intermolecular hydrogen bonding, it usually have the highest boiling point, followed by the permanent dipole attractive forces, lowest is the London forces. But if a molecule contains HCl, HBr and Hi, like all three are polar, then you have to look at which one has the highest London forces, because if all the types are the same, then we have to think about the number of electrons present, right? So higher the number of electrons, stronger the London forces. Stronger the London forces means higher the boiling point, right? Now the same thing happens even with the intermolecular hydrogen bonding as well. H2O and H2O2 both contains intermolecular hydrogen bonding, but H2O2 has higher boiling point. The one reason we can say, because it has two oxygen atoms, so that it can have more intermolecular hydrogen bonding. That's the one reason. And also it has more electrons, so it has stronger London forces as well. So H2O2 has a boiling point around 150 degrees Celsius, and H2O has a boiling point, we know it, 100. So H2O2 has a higher boiling point. So the boiling point mainly depends on the strength of the forces of attractions. Usually intermolecular hydrogen bonding has higher boiling point. Now if we talk about the boiling point of alkanes or the carbon chains, you can see they have isomers. So the boiling points of the isomers are not the same. So if I draw the skeletal formula, right? So if I take these three as A, B and C, commonly they might ask, explain the boiling rate trend in the boiling point. A has the highest, followed by B, lowest is for C. So simple idea is, if the molecule has branches, we say its boiling point gets decreased. The reason is, when there is a branch, its surface area decreases, so ability to have the contact places or the ability to form London forces gets decreased. Therefore the boiling point decreases, because A has the linear molecule, so it has more surface area, so more ability to form the London forces. Compared to A, B has a branch, so its ability to get weak. Compared to B, so it has more branches, so it has even lower boiling point. So that is how we normally explain the forces, the boiling point of a molecule. So we commonly get a question like with the similar forces of attraction, so the similar number of electrons, and they ask us to explain the trend in the boiling point. So if you get something like that, the same number or similar number of electrons but different forces of attraction, then what you have to discuss is you have to explain that, okay, this one has hydrogen bonding, this one has permanent dipole attractive forces, and this one has that, therefore it has a weaker or the lower boiling point. So we will do an example with a past paper, and I will explain that one to you, how we can explain the boiling point if they are given, and if they ask us to compare the boiling point of both polar and non-polar molecule. Right, so this is a past paper which came in 2021. It's a very common questions that come even for unit 4 papers as well. Anyway, so here you are given three molecules, fluorine, hydrogen chloride and methanol, and you are given their molar mass value
that is just to get an idea that they have same or similar electrons, so their London force strength would be the same. But you can clearly see the boiling temperature variation is very much higher, because fluorine has minus 188, hydrogen chloride minus 85, about 100 degrees more, and methanol is another 100 degrees more, about 80 degrees more than hydrogen chloride. So when you ask to explain this, they ask us to explain the large variation in boiling temperature given the small range of MR values, that means almost similar electrons. Detailed description of the forces involved are not required. So what we had to do is 6-mark question. So you can clearly see the fluorine is an unpolar molecule. So fluorine only contains London forces, right? You had to write fluorine is an unpolar molecule and only contains London forces. Then you can write hydrogen chloride is a polar molecules which contain permanent dipole attractive forces. And methanol, you can write it contains OH group, therefore it forms intermolecular hydrogen bonding, and it has permanent dipole attractive forces and London forces as well. Then you can write intermolecular hydrogen bonding is the strongest, and as they have the same number of similar number of electrons, London force strength is similar. Therefore hydrogen chloride would have a higher permanent dipole attractive forces, hence it has the second highest boiling point. Fluorine has a very low boiling point as it has only London forces. So that is a clear answer you can write, right? You can get 1.5 pages. So that's how you can write an answer, and I hope you get this. And every paper you will get something like this. Most of the papers you get something like this, right?
So if this is helpful, give a thumbs up and consider subscribing to watch more videos about the Edexcel syllabus, and thanks for watching.